Okay, last night's homework problem dealt with local linearity, which means if you have a curve and you want to find some values on that curve, you can estimate them close to a point by drawing a tangent line to that point. And then the tangent line can give you what are close to the values of the blue line, and the difference between the two of those is what's known as the error. Oh, that's terrible. I'll cross that out. Okay, so last night's problem gave us the function f of x equals 0.2x to the fourth, and it wanted us to find a tangent line, or a line of local linearity at x equals 3. Well, I know if I want to make a tangent line, I have to have, mama, x-rays, xylophones, yesterday. So essentially what I need is a point, I need an x value to enter in and a y value to enter in, and I need a slope. And everything is in front of me actually to find those. The f of x will give me the y value, and the derivative of f of x will give me the slope. So f of x is 0.2x to the fourth. F prime of x is equal to 4 times 0.2 is 0.8, x to the third. So now I'm going to find f at 2, and that's going to be 2 times 2 times 2 times 2, which is 2 times 2 is 8, 64. So as I was saying, I'm looking at f of 3, because I'm looking at x equals 3. So I need 3 to the fourth. 3 times 3 is 9, 3 times 3 is 9, 81. 81 times 0.2 ends up being 16.2. You can calculate that if you need to. And f prime of 3 is going to be equal to 3 times 3 times 3 times 0.8, which equals 21.6. So now I'm going to just demonstrate here really quick. F prime is going to be the m, x is going to be 3, and the y value is going to come from this equation over here. That's why a lot of times it's good to use this formula to find the equation for the line. And you don't have to use this formula, you can stick with the other one. I say forget your derivative and the cross-country team, and forget about you. What I really want to write in is our value 3. So L of x is going to be equal to 21.6 x minus 3 plus 16.2. And I already went ahead and graphed that in the calculator, and when I did, I got a nice tangent line that touched the graph right at x equals 3. And then it asked me to use that line to estimate and to find the error at 3.1. So into f of x, I put 3.1. And into L of x, I put 3.1. And I look to see what the difference is between the two. Oh, I am recording. So what I did was I put the 3.1 into this equation here, and when I worked it out, I got 18.36, giving me an error of 0.11. Okay, so this time we're using 3.001, which is closer to the value 3. You would expect much less error as you get closer to there. So I put 3.001 into the original function, and my calculator gave me back 16.2216. And then I put 3.001 into the equation for the line, and I got back 16.2216. And it looks like this time I have an error that is equal to 0, because I'm so close. The error may be in the thousandths or they replaced, but it doesn't show up on there. The closer you get, the less error you will have.